Okay, this is a question, a part B of a question from 2001. A DC power supply of EMF 6 volts and negligible internal resistance is used with a potential divider to generate an output voltage of 4.4 volts. The circuit is as shown in figure 6.2. And so you've got a resistor of 220 ohms here, a resistor of, we don't know, and a voltage of 4.4 volts coming out. Resistor Q has a resistance of 220 ohms. The output voltage is obtained across Q. Calculate the resistance of resistor P. Right, so if you have a wee look there, if there's 4.4 volts here, there's 1.6 here. And so you can put that into your V out, V in equation. So the V out, but we're calculating it across resistor P. So it's V in times R1 over R1 plus R2. So the input voltage, the output voltage we know is 1.6 and the input voltage is 6. 1.6 equals 6. We're going to call P R1, so we don't know it. And we are dividing that by R1 plus 220. So when you multiply all that out, you get 1.6 R1. Alright, I've cross multiplied first of all, I should have said, I suppose, and I'm multiplying it all out now. I get 1.6 R1 minus 352, and that's equal to 6 times R1. Sorry, that's plus 352. And then when you bring this over to this side, we end up with 352 is equal to 6R1 minus 1.6 R1. And that gives you 4.4 R1. And so to get a value for R1, you just divide 352 by 4.4. And the resistance comes out as 80 ohms. Second part of the question, a voltmeter is now connected across resistor Q. And it has a resistance of 2000 ohms. What is the reading on the voltmeter? So we have to calculate the total resistance here. So that parallel bit, I'm going to do it as a product over the sum, is 2000 multiplied by 220 over 2000 plus 220. And that gives you an answer of 198 ohms. So the total resistance now, the total resistance in the whole circuit is 198 plus 80, and that gives you 278 ohms. And then we can use that to find the current and then find the voltage across the parallel part. So the current in the circuit then, I'm going to do that down here. I is equal to V over R, and V is 6, and the total resistance was 278. And that gives you a current of 0.0021 amps. And therefore the voltage across the parallel part on its own is going to be equal to 0.0021 times the total resistance of the parallel part was 198. And that gives you an answer of 4.27 volts.